Hello and welcome back. In this video we are going to move to the Principles of Engineering Activity 1.2.4, number 4, which will be using the laws of circuit theory, solve for RT, IT, I1, I2, and I3. That's the total resistance and the total current. I1, I2, and I3, the currents through each branch of this circuit. This circuit right here, because we have branches that cut through the middle and each are connected back to the power source, this is a parallel circuit. So when we solve this, we will be solving using our rules for a parallel circuit. So let's take a look here at the first information they give us. First, we are given the total voltage. And based off our circuit laws, our total voltage is the same as the voltage across each resistor, and that is equal to 12 volts. So there's our first piece of information. Second, I haven't filled in yet our resistances. So each resistor is given. The first resistor is 8.2 kilo ohms, which means that it is 8,200 ohms. We're just going to take care of that conversion right away. Second, we have 6.8 kilo ohms, which would be the equivalent of 6,800 ohms. And finally, we have 4.7 kilo ohms for the equivalent of 4,700 ohms. All right, I'll slide over a little bit here to do my next bit of calculations. So we have total voltage. Let's work on figuring out our total resistance next. So in a parallel circuit, the equation I'll write down here for total resistance is technically 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So in order to get RT by itself, we need to cross multiply, and we'll have RT be equal to 1 over this sum. So we'll write it like this. RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So, how are we going to do this? We're going to come up here and we're going to break this down by plugging things in very carefully. So RT is equal to, I'll write it this way first, 1 over 8,200 plus 1 over 6,800 plus 1 over 4,700. If I were you, what I would do is do 1 over 8,200, do 1 over 6,800, do 1 over 4,700, find those answers, add them together, and then plug back in and do 1 divided by that total. What you should get when you do that, I'm going to let you try to do that on your own because I want you to practice that, and I'm going to tell you what you should get for your final. Your final answer should be 2075.7 ohms. So that would be our RT right there. Using those two answers, we can figure out IT, total current. Total current is going to be using our Ohm's law, so our total voltage over our total resistance, 12 volts divided by 2075.7, and that will give us a total current of 0.006 amps. To finish off, we then will find the current. The last three things it asks us to find is the current of 1, current at 2, and the current at 3. And we will again just use Ohm's law to do that. Sorry if I was moving that around on the screen. Hopefully we didn't lose too much information there. So we'll have voltage at 1 divided by resistance at 1, voltage at 2 divided by resistance at 2, and voltage at 3 divided by resistance at 3. Now, because of the information that we are given early on, we could have done all of this right away. We could have figured out each of these individually instead of doing all of this first. You could do it either way. I usually like to do the totals first and then go back and do my individual ones. You can do that on a parallel circuit. You can't really always do that on a series circuit. So moving on, we'll plug that in. We'll say 12 volts divided by 8200 ohms. 12 volts divided by 6800 ohms. 12 volts divided by 4700 ohms. And our final answers for those end up being 0.001 amps, 0.002 amps, and 0.003 amps. Now all of these are slightly rounded, so you may get slightly different answers. But what we can do is we can verify Kirchhoff's current law. And so we say 0.001 plus 0.002 plus 0.003 should equal 0.006, and it does. So we know that we have done our work properly.